Let's get over to a different screen. There we go. I think we're good. Is the volume down over here? That's unmuted. We're good here. Okay. So, okay, good morning. Oh, I'll put that in here. Hello and welcome, everyone. Okay. Hello. Good afternoon, everybody. So there was, if I remember correctly, there was a request last time, a couple requests to see a couple of problems on the Delta Math. There was a question about the 3 variables, which I'll go through. It's one of those ones that's kind of confusing to watch, so I don't know how helpful it will be, but I'll go over it with you. And then there was questions about, where is it? The writing systems of equations from context. So how to do that. And that's tricky because you can't memorize how to do that. You have to think your way through it each time because it's different every single time, right? Every systems of equations you ever run across in your life, you have to interpret that information differently. So you not only have to be good at math, you kind of have to be fairly strong reader as well, to sit down and have those skills to interpret the words and put them into mathematics. And it takes time. So don't be too hard on yourself. It's one of those skills that comes with practice. But here's the good news. Because it's a critical thinking skill, as you develop that skill, it's going to help you your whole life, because you might say, well, I don't expect to be doing that many systems of equations in the future. You might not. You could use them. Systems of equations are hugely helpful, and a lot of times people don't realize they should be using them. It's just one of those areas of math that people forget about and skip over. But even if you're not in a position where you'd be using systems of equations, that critical thinking that you develop by reading and interpret your reading into mathematics, that is a skill that will help you even outside of systems of equations. Being able to critically read something and digest that information and understand it and translate it into some kind of usable form, everyone can use that kind of information, whether you're going to be applying it to math or politics or a job or research or whatever. Being able to sit down and read critically, everyone should do that, right? Okay, so let's start with the linear systems and 3 variables. That one's kind of a pain. It's not fun, but we'll go through it and we'll check it out, and I'll show you how to do it. I'm probably going to have to shift this over. So we'll do this, linear systems and 3 variables. We'll talk about that, and then we will and then we'll go from there. These problems they're giving you are kind of set up to work a little nice. Like this one is set up to not be too bad. So I'll show you how it works. The good news is, basically, we have an additional step at the beginning of this problem. And then once you've done that initial step, you finish it just like the other steps. In other words, remember what we did with the systems of equations is we had a system of equations, and then we used either substitution or elimination to turn that into one equation with one variable. So we had 2 equations and 2 variables. After using the substitution or elimination step, you ended up with 1 equation and 1 variable. Okay, so if you think about that, what we're really doing is we're reducing the number of equations, we're reducing the number of variables. So what you do when you have 3 equations with 3 variables is we're going to take a step and we're going to eliminate it down to a system that has 2 equations and 2 variables. That's useful because you already know how to do 2 equations and 2 variables, right? You then apply substitution or elimination. So I probably won't do the entire problem just for the sake of time. I'll get it up to the point where I say, okay, now you know what to do from here, and then you can finish it out. And then we'll go over to those other problems that were asked about last time. And if anyone has, then we'll probably move on from this chapter. So if anyone still has questions about systems of equations, throw it in chat, and then we can see if it makes sense to go over it or what we want to do about that. But let's start off with this one. So let's start off with, so let me write this down so I don't have to keep switching back and forth. Let's see, do I have this right? Okay. Okay, so I'm going to go over and we'll do it here. Move this over a bit more, and I'll show you how to do this. So we want to solve the systems of equations where we've got 8x minus 3y plus 5z equals -2. And the good news is the step we have to do is just an elimination step. So you actually already know how to do that. You just haven't seen it done with a problem like this before. So it's almost like there's not really anything new. It's just we're using it in a new way. Okay, so 3 equations, 3 variables. This is where these problems get to be a little bit tedious, right? The 2 equations and 2 variables, the truth is, for the amount of time it takes you to put it into a software program, you probably could solve the thing by hand. It's about the same amount of time either way, so one doesn't really save you much. By the time you get to 3 equations and 3 variables in the real world, you're probably not going to solve these by hand. That's why I don't spend a ton of time on them. In reality, anyone who has to solve 3 equations and 3 variables is going to put it into Wolfram Alpha or some other computer algebra system that you're using at your university or college or job or something like that, and have it solved for you. MATLAB, Maple, something like that, and have the systems of equations solved for you. And especially once you get to 4 equations, 4 variables, forget it. Like, I mean, you could do it if you wanted to, but 4 equations, 4 variables might take you 25, 30 minutes, right? Why not just put it in the computer and have the computer do it for you? So, we're supposed to cover this in this class, but just do be aware. I understand in reality, you're probably going to put this in a computer if you ever have to do this. But it is helpful to know the procedure so that you understand what it is that you would do. Okay. So like I mentioned, our goal here, step 1, the new step, is to use the elimination process, what we talked about last time, the addition method, the elimination method. We're going to use that to eliminate one of these variables. Now we have to do it twice because remember we're trying to get to 2 equations and 2 variables. So we're going to use elimination once to get one equation and 2 variables. And then we're going to do it again on different equations to get another equation in 2 variables. Okay? 2. So to me, when I look at these, it kind of pops out at me that it looks like z is going to be the easiest variable to eliminate, right? Because I have a -5z. Well, if I add that to equation 1, my z's are going to cancel, right? But also, look, if I add it to equation 3, my z's are going to cancel. Great. That's the whole thing we have to do right now. That's the new step. Once we've done that step, so we do those 2 things I just mentioned, now all of a sudden you're going to have 2 equations and 2 variables, and you already know how to solve those. You've been doing it. That's what you've been doing throughout this chapter, right? So here's what I'm going to do. Let's give myself a space here and say add equation 1 and equation 2. And I just explained why, so I'm not going to write out the whole thing. It's because I can see these z's are going to cancel. You have to make sure for this first step, you eliminate the same variable from the equations. If I eliminate z from one equation, and then I eliminate x from another equation, when I still have 3 variables in that system, right? I'd still have an x, y, and a z. We want to make sure we're eliminating the same variable both times. In this case, we'll just end up with an x and a y, no z's, okay? And then we'll come back at the very end of the problem and solve for z, but it's easier to do. It's good to go, okay? So add equation 1 and equation 2. So I'm just calling this first one equation 1, the second one's equation 2, third one's equation 3. So E1 means the first line, E2 means the second line. So when I do that, when I add those together, I get what? 9x minus 5y. My z's cancel. That was the whole point. Now, what if my z's didn't cancel perfectly? Like in this problem, it's set up for 5z and -5z. You do exactly what you did in elimination last time, where you multiply the equations by something that's going to make it go away. That's what you would do, right? But in this case, we don't have to. So I'd get 9x minus 5y equals negative 11. Does everyone understand what I did there? I just added those first two equations together. The z's canceled. If the z's weren't ready to cancel automatically, I'd multiply the entire equation by something so that then they would cancel. Just the step you did last time. Okay. Now I'm going to add equation 2 and equation 3 because I can see those are going to have the z's cancel. But remember, I want to eliminate the same variable that I just eliminated here. Because if I don't eliminate the z, see how we already have an x and a y in this first equation? And then if we leave a z in the third equation, we'll have 2 equations, but 3 variables. That's not good, at least for what we're trying to do. So when I do that, I'm going to get what? Oops. I add those, I'm going to get 5x plus 5y equals 5. Wait a minute. Did I do this? Oh, yeah, that's right. So notice, what do we have now? We have 2 equations and 2 variables. You know how to solve those. That's what we've been doing throughout the chapter. So you could finish from here. In fact, it looks like this is going to be fairly straightforward because this problem is already set up for elimination again, right? When I add these together, what would I get? In fact, this one's set up to work really nicely. Let's just finish it off. So now I'm going to add, I guess I'll call these equation 4 and equation 5. These two right here. Look what happens when I do that. I'm going to get the 5y's cancel, and I'm going to get 14x equals, let's see, negative 11 plus 5 is going to be negative 6. Did I do this right? I hope I didn't mess up. 14x equals negative 6. I may have made a mistake somewhere. Let's see. Just want to make sure here before I get too far. So, oh, I did write this down wrong. See, this is what I've been warning you about. I just made that mistake myself. I even checked and I still messed it up. This should have been a negative 8x in the front of my equation, negative 8x. So this should be up here. So just to make it clear, I wrote my first equation. Yeah. So someone's pointing it out in chat. That's right. It was negative here. So that's where my mistake was. Which means down here, when I add these together, this should have been a negative 7x. So when I add these together, this should have been a negative 2x. So sorry about that. When you're doing this stuff live, it's easy to make a mistake here. That looks more likely the case. So let me just double check really quick. Negative 7x, negative 5y, negative 11, 5x, 5y, 5. Add these together, I get negative 2x, negative 6. Okay, that looks right. Easy to make a mistake here, as you can see. I just did it. So now we've solved for one variable, right? X equals negative 3. Okay. So remember what we have to do. What do we do in these systems of equations when we solved for a variable or some variables? We go back and try to find an equation that has that variable in it or variables that we know and then one additional variable. So right here, we know x equals negative 3. So I'm going to try to find an equation that has an x and one other variable. Well, look, we've got them right here. How about 5x plus 5y equals 5, right? So I'm going to plug x equals 3 into this right here, the equation that has 2 variables. So when I go back and do that, I'm going to get, like, I can't go back to the original equations yet because then I would have 2 unknown variables. You can't solve for 2 unknown variables. We have to solve for 1 unknown variable. So I'm looking for something that has an x and another variable. So let's take this one. So we're going to do, that's going to be 5 times negative 3 plus 5y equals 5, right? Which is negative 15 plus 5y equals 5, which becomes 5y equals 20. Am I off the screen? Sorry if I'm off the screen here. There we go. 5y equals 20. We divide and get y equals 4. Y equals 4. Okay, so normally once we find 2 coordinates, we're done. Except we're solving a system that has 3 equations and 3 variables, meaning we need to find all 3 variables, x, y, and z. We found the x and y, so now what should we do? Well, now we go back to the original equations because we know an x, we know the x value, we know the y value, we need to solve for z. So now you go back to where you know 2 of the variables and there's 1 remaining, and you pick whichever of these you want to use. It doesn't make any difference. Let's do the third one. 4x plus 7y plus 5z. So let me grab this one. So that's plugging things in. That's going to be 4 times, let's see, x was negative 3. Negative 3 plus 7 times 4 plus 5z equals 4. Right? So I'm just taking the one of the original equations, I'm plugging in my x and y value, and we're going to solve for z now. So when I do that, I get what? Negative 12 plus 28 plus 5z equals 4. Let me know if I make a typo here. Okay, so that's going to be what? 28 minus 12 is going to be 16. Subtract 16. That doesn't look right, does it? Negative 12. Did I copy that right? That doesn't seem like it's going to come out right. Let me see, though. So that would be 16 plus, right, y was negative 3? X was negative 3, I mean. 16 plus 5, x equals 4. So I'm going to get a fraction, which makes me think I messed something up. Maybe not. Maybe these, I forget if these can come out with fractions or not. So 5x equals negative 12. So x equals negative 12 fifths. So x was what? Negative 3, y was 4, and we're saying, I might have messed it up. Let's see, negative 12 fifths? No, not correct. Let's see, what did I do wrong? I think I've made a mistake in this last part. Let's see. It can be a little tricky to Oh, you're right. I didn't cancel my negative here. Thanks. Thanks for pointing that out. So this should be positive 3, which would mean this would be, oh, so it would fix all that. So 15, so that would become positive 15, which then when you subtract would become 5y equals negative 10, which would mean y equals negative 2. So this would be positive 3, negative 2. So this would be positive 12 minus 14, which would be 2, negative 2. It's still not going to come out right. Let me check something really quick. Anyways, I've made a mistake in here somewhere that keeps messing it up. So as you can see, these are a pain. This is why I don't make a big deal out of these, because in reality, you don't, no one solves these by hand. And you can see why. It's super easy to make one little mistake there, and then it carries through that entire problem. And when you're trying to find where the mistake was made, it's hard to do. So, I'm doing this live, which is a little more difficult, but that's why I don't put a huge amount of emphasis on this. We'll try to work through them. I'm required to make you do a few of these, but it's kind of left over from a previous age where, 20 years ago, it was hard to find software that would solve systems of equations for you. Now it's actually quite easy. So I apologize for if I confused anyone with the with my mistake that I made in there that I can't seem to root out. The bottom line is when you're doing these, use elimination to eliminate one variable. So pick 2 equations, eliminate a variable using addition or elimination method. Pick another 2 equations, eliminate a variable using elimination, and then go from there. I definitely made some kind of mistake somewhere in there that it keeps messing it up. So sorry if that was confusing, but that's the process. You're going to use elimination method twice to get down to a 2x2, 2 equations, 2 variables, and then you're going to solve it from there just like normal. I probably have a sign error somewhere that I messed up or something. Or I wrote the problem down wrong still or something. I'm not sure. But that's the idea behind those kind of problems, okay? So you won't have this kind of problem on a test. Like I say, I don't think it's particularly useful to make students do these by hand. Unless you're in a linear algebra class, then they make you do a few of them, and then we go to the TI-84 calculator to do them for us anyways. So so don't sweat it. Try to get the homework points if you can, but I definitely will not ask you one of these on the exam, right? You will have to do systems of equations on the exam, but I even in my in a normal classroom, I don't ask 3 equation, 3 variable systems of equations. So, don't think that's going to be on the test or something, okay? But that's the procedure for how you go through and do that one. All right. If anyone has questions, feel free to see me at office hours, and I can help you through them. Okay. Stuff that is much more useful, and I think this, if I remember right, this was asked about last time, write systems of equations from context. There's kind of 2 here. There's write systems of equations from context and then solve systems of equations from context. But if you know how to write systems of equations from context, well, you already know how to solve a system of equations once you find it. So really the thing that's complicated is write the system of equations from context, right? So we have to do that one. And you've got, so we'll work through that. Whoops. Okay, so we'll work through that part because there was questions on that, and that's actually a very useful skill that is like I say, important outside of just the course. Okay. So basically, be a critical reader, right? Critical thinking, critical reading, understanding what you're reading. Don't just blast through it. You can't do that in mathematics. When things like, it's not like reading a novel where you can just read paragraph after paragraph, page after page. With mathematics, you got to stop all the time and go, okay, do I understand what I just read? Because you can read faster than your brain can convert information. So you have to stop regularly and let your brain catch up. Okay, so let's see. A paper company needs to ship paper to a large printing business. Okay, so our problem is about shipping paper. Okay, got it. The paper will be shipped in small boxes and large boxes. Okay, we got two different kind of boxes here. Small boxes, large boxes. We're probably going to have to keep track of those. Let's see. The volume of each small box is 9 cubic feet, and the volume of each large box is 24 cubic feet. Those are big boxes. That's a big box. Okay. So that's not like your typical box, right? 9 cubic feet. Okay. A total of 24 boxes of paper were shipped with a combined volume of 441 cubic feet. Now, I don't have all this stuff memorized, but I'm remembering the basics as I go through the problem. Okay, remember there's two size boxes. Each box has a known size. We've been given the size. Off the top of my head, I don't remember, but we can always go back and double check if we need to. And then we know that 24 boxes of paper were shipped, and there's a total cubic volume. So does everyone understand a cubic foot? You've got feet, which is a length, right? So that's a linear measurement. You can measure how long a wall is, for instance, right? You say, okay, I'm in a room. The wall is 12 feet long, okay? Square feet is area. So if you wanted to know how much carpet was in the room, you wanted to replace the flooring or something, that's a square foot is a square that's 1 foot by 1 foot. So if you had a bunch of tiles that were 1 foot by 1 foot and you placed them down in the room that you're in, however many tiles you place down when you put them down nicely so they're not overlapping, however many you put down in the room, that's the number of square feet in the room. Okay? So that's like how you measure flooring, carpet. Cubic feet, that is if you have a box that is 1 foot by 1 foot by 1 foot. So that is a volume measurement. You're measuring the volume of something, okay? So like if you have, say, one of those little aquariums that's 1 foot by 1 foot by 1 foot, and you got a little fish swimming around in it, you have 1 cubic foot of water, okay? We are talking about cubic feet of paper. So we are literally filling space with paper and then measuring how much of it there is. Or at least, that's what these boxes are meant for. Write a system of equations that could be used to determine the number of small boxes shipped and the number of large boxes shipped. Define the variable that you use to write the system. Okay, there's more than one way to do this problem, actually. With systems of equations, there's actually a lot of different ways you can do the problem. But for setting up these variables, there's two different ways we could do it, and they both work. So if you're looking at what I'm doing and going, that seems backwards to me, that just means your brain works a little bit differently than mine. Doesn't mean you're wrong, doesn't mean I'm wrong. It's just doing it differently, right? Okay, so we have to define what these variables are. And you can, I forget if it's going to, forget if it makes me use X and Y. It might not. You can use the X and Y variable. Also, sometimes people want to use variables that make sense. Because if I use X and Y, you're going to go, well, which ones? I forget if X is the small boxes or the large boxes. I don't really remember that. it's easy to mix them up. But if, say, you were smart and you used S and L, well, you're probably not going to think that S is the large box and that L is the small box, right? So sometimes it makes sense to pick variables in that way. So just to keep it simple, I'm going to choose X and Y this time, but you always want to write what those variables are equal to. This is a step that I see people skip a lot because they go, well, I just said what they are. Why do I have to write it down? And then halfway through the problem, they get confused and they flip them. And then their answer, even though their math is correct, they answer the problem backwards. And then they get it wrong, right? Unfortunately. So even though you did all the work right, because you were kind of lazy and you didn't write down what your variables were equal to, you end up making the wrong decision. And, you know, sometimes a student will say, well, I did the math right, but it doesn't matter if your conclusion is wrong. If you're at a company and they want to know how many of each type of box to buy and you mix up the numbers, is your company going to care that you did the math right, but you just gave the wrong recommendation? No, they're going to go, you're getting written up because you cost us a ton of money because you were sloppy with your mathematics, right? So you have to be strong beginning to end, right? Okay, so let's choose X. I'll just go with X and Y for now. And they're kind of giving you some options here. In the real world, you don't have these options. You have to figure it out on your own, but they're kind of helping you set it up. So let's see. What would we want to come up with here? Let's look at our choices. The volume of the small box, the volume of the large box, weight of the small box, weight of the large box, number of small boxes, number of large boxes. Which one makes sense there? Well, let's look at the first two. The volume of the small box. Well, we already know the volume of the small box. That was given in the problem, right? So why would we solve for something that we already know? That would be silly. We spend a bunch of time to figure out that the small box is 9 cubic feet. That's given in the problem. So it's definitely not that. Likewise, it's not the volume of the large box because we're given that information in the problem. So I can already eliminate the first two. Okay. We've got the weight of the small box and the weight of the large box. So going back and looking at the problem, I don't see anywhere where people are talking about weight. Like why are we talking about weight all of a sudden? No one mentioned weight, I don't think, unless I'm missing it. That doesn't seem relevant because that seems like it would belong to like a different problem, right? Okay. So the number of small boxes and the number of large boxes, that actually makes sense because what is our question here? Our question is, write a system of equations that could be used to determine the number of small boxes shipped and the number of large boxes shipped. Now that makes sense that the thing I'm being asked to figure out would be the variable that I'm defining. Yeah, that makes sense. Okay, let's go with that. So you just pick one. X is the number of small boxes shipped. Y is the number of large boxes shipped. Now, if you did it the other way and you said Y is the number of small boxes shipped and X is the number of large boxes shipped, that's fine. That'll work. You'll still get the right answer. It's just your X and Y will be switched from mine. But when you go back, you'll remember that your Y is small boxes and your X is large boxes, so you'll still get the answer right. You'll still do it correctly. It'll just look a little differently than mine. Okay, now that we have our variables defined, now we have to figure out, okay, so what would my equations be? So what you're going to do now is you're going to go back and you're going to look for information in the problem that you can use to form an equation. And I wish I could just give you like a golden rule that says this is how you do it every time, but there isn't one because every systems of equations is different. There's not any one way that I can say, here's how you set up your equations. It comes with experience and practice. After you've done a few of these, I know it's hard in the beginning. After you've done a few of these, you go, oh, I get how this works. It makes sense to me now. And then you'll get better at it. You'll be good at it. But it's a little tricky in the beginning. So let's see. What's the information we haven't used? So the volume of each small box is 9 cubic feet. And the volume of each large box is 24 cubic feet. A total of 24 boxes of paper were shipped. Okay, just think about that information right there. A total of 24 boxes of paper were shipped. Okay, can we form an equation from the information a total of 24 boxes of paper were shipped? A lot of times with these problems, it's not always the case, but pretty frequently you get one easy equation to make and one hard equation to make. Sometimes they're both hard. Occasionally, once in a while, they're both easy, but usually they're either one's easy or neither one is easy. In this case, we have an easy equation. A total of 24 boxes of paper were shipped. Okay, well, we have a representation for the number of small boxes that were shipped, and we have a representation for the number of large boxes that were shipped. So what would x plus y be? X plus y would be the number of small boxes shipped plus the number of large boxes shipped. Well, those should total out to 24, right? So our equation should be x plus y equals 24. There's one equation right there. That's the easier one. And I'm saying it's easy. If you didn't get it, don't go, oh, well, why didn't I think of the easy one? I'm just saying in the future, like once you get the hang of these, you'll recognize when there's a total. If it gives you a total in the problem, sometimes that means you have one like simple equation. Not always, sometimes. Okay, this next one's going to be more complicated. Okay. So we have a total of 444 cubic feet. So we want to figure out how many cubic feet were sent out in the small boxes, how many cubic feet were sent out in the large boxes, and then we have a total cubic feet, right? So if I take 9, there's 9 cubic feet in each small box, and there's x boxes. So what does 9x represent? 9x represents the amount of cubic feet that was shipped in the small boxes. It is the volume shipped in the small boxes, right? See how I'm taking the cubic feet for the small box? So it's the volume of the small box times the number of small boxes shipped gives us the total volume from small boxes. Okay, well, let's play the same game with the large boxes. So plus, let's see, a large box is 24 cubic feet. So if I do 24 times y, well, the volume of a large box times the number of large boxes shipped, that gives us the volume of the volume shipped from the large boxes. Well, if I add those together, the problem says that should equal 441. Okay, so this should be right if I did it right. Let's submit the answer. Is this what you want? Yep. There we go. Green check. We did it right. Okay. So define the variables. Notice they went with the other one I suggested, S and L. It's smart, right? This is part of the working smarter, not harder. If you use variables that suggest which thing you're representing, you're less likely to mix them up, right? Because where we had it with X and L, you have to go back and ask yourself, wait, was X the small boxes or the large one? But if you use an S and L, you're going to remember, right? I couldn't remember if the software would take S and L, but it's a good choice to use those. It'll take X and Y, but it's kind of smarter to use S and L. So then that's exactly what we did, right? We set up our variables just like this, and then we constructed some equations. The total number of boxes is 24. The total volume shipped is 441. That's all that one means. Okay, I think we have time to do one more. Let's try that. Okay, Harper went into a movie theater and bought 10 bags of popcorn and 6 drinks, costing a total of $79. He really didn't want to run out of popcorn during the movie. Damien went into the same movie theater and bought 3 bags of popcorn and 5 drinks. These people drink a lot. Costing a total of $36.50. Write a system of equations that could be used to determine the price of each bag of popcorn and the price of each drink. Define the variables that you use in the system. Okay, so let's see. A couple choices. You could use B for bags of popcorn. You could use P for popcorn. Probably makes sense to use D for drinks. So I'm going to use D for drinks and P for popcorn. Just makes sense. I'm not going to mix them up. I'm not going to think that P stands for drinks and D stands for popcorn. Probably not, right? That'd be a stretch. Okay, so which one is it? The number of, so here's some choices. The number of all items? No. The price of the items? Probably not. Really, we're looking at the number of bags of popcorn. Part of this is given away. Actually, that's not what we want to do. We want the price of each bag of popcorn. And here we want the price of each drink, right? It's a good idea. Look at what they're asking you to figure out, and that's going to be a pretty good indication of what your variable should be. It's a little bit of a cheat because in the real world, the questions are not usually posed this way. But while you're first getting used to systems of equations, it's a good indication that that's what your variables would want to be. Okay, so how do we do this one? Well, let's take the sentence about Harper and see if we can construct an equation from that. So 10 bags times the price of popcorn plus 6 drinks times the price of a drink should equal $79. Now let's do the same exact thing, but for Damien. So 3 bags of popcorn plus 5 drinks. For him, that was a total of $36.50. Right? And there we go. They used B for bags, but it was fine using P. It still gave me credit. Right? So that's actually a really important step. Students try to skip this step when they're doing homework, and then they wonder why they're having problems with the actual setting up. Like, they try to skip this defining the variables piece, and they try to go right to the systems of equations. And I'll go around the room, and students will ask me questions, and they'll say, I don't understand how to write the system of equations. And I'll say, well, what are your variables? And they'll go, I don't know. You have to do that step first. How could you possibly build an equation from variables if you don't know what those variables represent? You can't do it. It doesn't make any sense, right? It's like trying to build a house, but you don't know what your construction materials are. Well, you can't start building until you know what you're using to build the house. Then you can start designing the thing. It's the same thing here. We cannot write our equations if we don't know what these variables are. So if you find yourself having trouble writing the equations, ask yourself, do I know what my variables are? And if you haven't defined them the way we did up here, then the answer is no, you don't know what they are. You might have thought about it and go, I think I know. But if you can't write it down on the paper, then you don't know what they are. So that's step 1. And it's unfortunately students really like to skip that step. Do that step. And then it makes more sense to write your equations, because what you're going to see is patterns. After you do a few of these, like this problem was different than the last one, but there's only so many variations of these problems. Once you've done a few of these, you're going to go, oh, this is like that one popcorn problem. And then you'll go, oh, I remember how to set that one up. Or you'll go, oh, this is like that one problem, which, what was the one we did a minute ago? It was shipping paper. You go, oh, this is like that paper shipping problem. And then you'll learn how to set up those equations. So the first few can be really challenging, but once you get them done, it's like it's almost like you're doing the same problem again and again, but with different numbers in it. So once it clicks, once you see how the problem works, it gets easier, right? It gets better from there. Okay. So hopefully that helps you with that. So I think unless I get feedback that we're not ready for it, I believe next time we will go to, next time we'll spend a little bit of time talking about inequalities. I probably will, actually, if I remember right, I think most of the people did this homework already. So it looked like people were pretty good. I think next time we'll dive into scientific notation and exponent rules. Exponent rules are tricky for people. We probably want to spend some time on that. Scientific notation, people usually find scientific notation confusing when they first see it, but then within like 10 minutes, they're good with it. They're like, oh, this is not hard. Exponent rules take a little bit longer. So we'll talk about that next time. What is today? Today's Wednesday. So I'll take a look. It looked like people were doing fine with inequalities. If there's a lot of problems with inequalities, let me know, and then I can cover stuff. But let me know which things you want to see. Like, let me know, maybe send me a screenshot of the problem or the title of the problem so that I know which ones you want to see. Because I think we don't need to spend a huge amount of time on it. It looked like most like a bunch of you have already completed that with 100%. And others are close, like 80% on the topics and stuff like that. So let me know if you need to see any of those. Otherwise, I'm going to start off with scientific notation and exponent rules next time. Okay. And yeah, so I'm going to shut down the YouTube stream, archive it. Anyone who wants to talk to me in Zoom, hop on in. Let me answer your questions for you. Okay. Thanks, everybody. We'll see you later.